Hey guys, and welcome to the Everyday Consumer Products revision video. This isn't going to be a very long one. There's not a lot that you need to know for everyday consumer products. Essentially, the two main things are alcohols and carboxylic acids. Okay, so let's go through it. So an alcohol is a molecule that contains the hydroxyl functional group. Okay, and remember, a functional group is just a part of a molecule that does a job. Okay, and the alkenes, that is the double bond. The double bond allows it to do different types of reactions. Alcohols, that is the hydroxyl group, that OH group that you see in all alcohol molecules. They have the general formula CnH2n plus 1 OH. Okay, and the number in the name indicates the position of the hydroxyl group. So propan-1-ol has the hydroxyl group at the first carbon. If you're looking at that image, remember you can count the number of count the carbons from either side. So they're counting from this side so that the OH group is the lowest number possible, 1, 2, 3. Okay. Propan-2-ol has the hydroxyl group on the middle carbon. Okay. Remember when you're drawing these to make sure the bonds are going to the correct place. Remember, oxygen can make 2 bonds because it's got a valency of 2 because it's in group 6. Carbon can make 4 bonds, etc., etc. Just make sure that I've got no bonds going from in the hydroxyl group that's going from the carbon to the hydrogen and then the hydrogen to an oxygen. Hydrogen can't make 2. And sorry, I've lost my train of thought. Hydrogen can't make 2 bonds and oxygen can't make 1. So make sure we've got the bonds orientated in the right way. Okay, just some uses. So fuels is the main use for alcohols because they're highly flammable. They burn really nicely because of that oxygen. Remember that complete combustion is not required. Complete combustion occurs when there is enough oxygen to burn the molecule completely cleanly. Alcohol kind of has its own supply of oxygen because it's got that oxygen atom in it. That helps the process. It means it's much more likely to do complete combustion because it's already got a little bit of help from that oxygen atom. They also used for solvents, so used to dissolve different types of molecules. Okay. Remember that the word miscible basically means mixes with water. Okay. So the smaller the molecule, the more likely it is to be able to mix with water. It is miscible with water. The bigger it gets, the less likely it is. Okay, solubility decreases as size increases. And like in the homologous series video, melting and boiling points increase as size increases due to the increasing strength of intermolecular forces. The bigger the alcohol, the higher the melting and boiling point because those intermolecular forces are stronger. It takes more energy to pull them apart. Okay, that's all you need to know about alcohols. Let's talk about carboxylic acids. Okay, so carboxylic acids are molecules which contain a carboxyl functional group, commonly referred to as the COOH group. Okay, COOH. General formula, CnH2n plus 1 COOH. For example, you've got methanoic acid there, which has that 1 carbon, which is why it's meth, with the double bond O and the OH group. Butanoic acid has the 4 carbons, why it's called butanoic acid. And sorry, the wind just blew that door slightly open, and I thought someone was coming in to murder me. And got the OH group. Okay. So, uses of carboxylic acids, making preservatives, soaps, and medicines. You need to know that vinegar is a solution of ethanoic acid used in cleaning products as it's non-toxic. And like the alcohols, you've also got these properties. So, methanoic to butanoic acid are miscible with water, and the solubility then decreases. And again, melting and boiling points increase as size increases due to the increasing strength of intermolecular forces. Okay. One last thing you need to know about carboxylic acids, they're an acid. That's literally in the name. So carboxylic acids have a pH of less than 7, so react with bases in neutralization reactions. So carboxylic acid plus metal hydroxide or metal oxide gives you salt and water. Carboxylic acid plus metal carbonate gives salt, water, carbon dioxide, the same as in the acids and bases topic. Okay. You can also react them with metals to form salts and hydrogen gas. So carboxylic acid plus metal gives salt plus hydrogen. And then quickly, just about naming salts. When you're naming a salt from a carboxylic acid, if you take away the ic acid part of the name and replace it with ate, that will help you give the non-metallic part of the salt name. So remember, the base still gives you the metal. So sodium hydroxide is the base. Your salt will still start with sodium. Ethanoic acid, take off the IC acid and put ate on, and that gives you ethanoate. That's the second part of the salt name. So sodium hydroxide and ethanoic acids forms sodium ethanoate plus water. Okay, and that is everything from the everyday consumer products video. Feel free to go on and do the mind map. That is linked in the Teams post. And after that, there are some past paper questions. Feel free to do those. And if you have time, absolutely go back and choose another video to start with and see where you get to. Okay. I shall see you all in a bit. Thank you, guys. Bye.